Hello and welcome to the tutoring video for Acadec Focus Quizzes 18 through 20, I think. Pyramids, cones, and spheres. I'll be honest, I do think these are pretty easy. So there are three of them, but they shouldn't whip you too bad. Let's hop right in. All right, so pyramids. I just did this whole thing and literally saw this, didn't change it. Volume of a pyramid is very similar to the volume of a prism, which is why I Freudian typed, I guess, and wrote prism there. So it is the same formula, pretty much, the area of a base times the height times 1/3. So say if you have this square pyramid, if you had a square, like a cube, right? Square prism or whatever. Wow. If you had a cube and it had the same side lengths and same height, but it filled in all the rest of the void around the top of the pyramid, if a cube was around it, then it would be 3 times bigger in volume than the pyramid. If none of that made any sense, don't really worry about it. More of a fun fact. This is the formula for the volume of a pyramid. And this big B means area of the base. So for a square one, that's the side length squared. And square ones are pretty common, so keep that in mind. The surface area is, there's 2 different ways to do it, right? You can find the area of the base and then find the area of one triangular side and multiply that times the number of triangular sides there are. Or you can find the area of the base and add 1/2 times the perimeter times L, which is the slant length. Now you need to find or have the slant length for either method. So it doesn't really matter, and you'll see that in a second. But there are certain problems where they will give you the perimeter, but not the number of sides or anything like that. So you have to use this formula instead of finding the individual areas of the sides of the pyramid, because you have no way of knowing how many sides there are or how long the lengths of the individual sides are, even if you do know that it's like a rectangular pyramid or hexagonal. You know, if it's not a regular polygon base, you wouldn't know. So you need to know this equation, and you can just use this one. But if this one's easier for you, do that one. And this is the one I'll do for the first problem, and then I'll use this one for the rest of them. So this is straight from the math resource so that there's a pretty picture, because I can't draw. And this will help you visualize it. This is one of the few tests that I wouldn't really recommend drawing a picture for unless you are just drawing this little cross section to help you figure out the Pythagorean theorem. Because maybe you can draw this. I can't. If you think you can, cool, rock and roll, power to you, but I can't. So it doesn't really help me to do it. Maybe you want to draw like just this and maybe like the slant height. If that helps you keep track of things, like 5, and if it's a square one, 5, and then once you figure this out, you can label it. Up to you. I think mostly these problems are not too hard to just do it with the formulas. So, for this one, a square pyramid has a base length of 5 and a height of 8. We want to find the volume and surface area. So our volume equation is that 1/3 area of the base times height. And our surface area, I'm going to use area of the base plus the area of all 4 sides. So we're going to have to find 1 and then multiply it times 4. And I'm going to denote that area with T for triangle. But first, let's find the volume, because that's easier. So our base area is just 5 squared. So that's 25. So we have 1/3 times 25 times the height, which is 8. And we can go plug that in. 1/3 times 25 times 8. Control Enter is this. Right? So that's our volume. Now for our surface area, and here's another thing. Sometimes they will say lateral surface area. That just means all of the triangle sides, everything that is not the base. And that can be found with that 1/2 P times L, or by getting an area of all the triangle sides. So that's the same as the prism. The second part of the equation that you're adding on is the lateral surface area. Everything but the base or bases. So for this one, the area of our base is still 25. Let me box this off. Still 25. But the area of those triangles, we have to find, this is called the slant height. All right, or the slant length, or whatever. So we know that we can find it using Pythagorean theorem. So to do that, we're finding half of the side length here, because we have to split this down the middle to make a right triangle. And we have the height right here. So we're going to use Pythagorean theorem to find this length. And that's a squared plus b squared equals c squared. So if we just skip the middleman and say the two shorter sides added together squared under the hood of a square root, we get 8.38 is what we're going to leave it at. And that is our slant height. And for this one, I'm just going to use the triangle formula, and then on the next ones I'll show you the perimeter one, because we could use either at this point. It doesn't matter, whichever one is easier for you. So we have this times, or rather plus, sorry, 4 times this, using this rather, and the area of a triangle is 1/2 base times height. So the base of this triangle is 5. We have 1/2 times 5, and then our height is that slant height, 8.38. So if we go plug this in, 4 times, and those are all multiplied together, so I don't even know why I added the parentheses. 4 times 0.5 times 5 times 8.38 equals 108.8. So that is our total surface area. Not too bad, right? And the units on these is, say these were just plain units. The volume is cubed, and the surface area is squared, if you care. All right. A square pyramid has a base length of 7, and that just means that all of the sides of the base are 7 units long, and a height of 13. Find the volume. So for the volume, we have our 1/3 area of the base times height, and the area of our base is 7 squared. 7 squared, and our height is 13. So all we gotta do is go plug that in. 1/3, oops. I always do this because sometimes the calculator does some pretty funky auto parentheses if you don't. I separate it as much as I can so I don't have to retype it later anyways. Times 13. Oh, control enter. And our height is 212.3 repeating units cubed. All right. Find the base area of a pyramid if the total surface area is 351 meters squared. I gave up on using the superscript, is what it's called, because it's so finicky and I just didn't feel like it anymore. You know what the caret means. The slant height is 15 meters and the perimeter is 36. So this is why you need to know that other equation for the perimeter, because there's no way to figure this out without knowing that. So our equation is area of the base plus 1/2 perimeter of the base times slant height. And we have all of those things except area of the base. So we just fill out our thing. 351 equals B plus 1/2 36. 1/2 times 36 times 15. And we don't use NSolve for this. This is very easy. We're going to find this and subtract it from both sides, and that will be our base area. If it was, well, that doesn't matter. So 0.5 times 36 times 15. Yep. 270. Then we take our 351 and subtract 270, 81. So our base area is 81 square, oh, not units, square meters. Not too bad, right? Here's another one. A square pyramid has a volume of 240 cubic meters and a height of 5 meters. Find the side of the base. And I wrote it like that on purpose because the question that I based this on / plagiarized and changed the numbers worded it weirdly like this. So that's why it's worded like this. That's why several of them are worded kind of weird. Is because I don't want you to freak out when you read it and it is not exactly what I said. Like a normal human might say it. So our equation is 1/3 area of the base times height. And we know everything except the area of the base. Now it's a square pyramid and that's important. So 1/3 area of the base times 5 equals 240. So we're going to multiply both sides by 3 and divide by 5 to get rid of this 1/3 and 5 respectively. So 240 times 3, 720 divided by 5 is 144. So that's the area of our base. But it wants the side. Because this is a square, the area is just the side length squared. Right? So the square root of 144 is 12. So our side length is 12 meters. Cool. And if you don't know what the square root of 144 is, no shame, put it in the calculator. Okay, cones are extremely similar. Pyramids and cones share the same relationship that prisms and cylinders do. A cylinder is just a prism, but the base is a circle. And a cone is just a pyramid, but the base is a circle. So the math changes pretty significantly because circles are pretty significantly different from other polygons. They're not polygons technically, but you know, if you did an infinite number of sides, they would be the infinitely sided polygon. Anyways, volume of a cone is the same, but you get the area of the base differently, right? Instead of a lot of square pyramids or them just giving you the area of the base, you need to know that it's pi r squared. Either for reverse engineering or reverse finding the radius from the area of the base, or they just give you the radius and you need to find it. The surface area is technically that same B area of the base is what this is, that pi r squared, plus, and this is the lateral surface area. This is pi times r times the slant height. All right? So this is lateral surface area. It's the exact same as the pyramids. You just got to find these differently. I included this. It's from the resource just so you can further see radius is r, and I'm not making up this slant height as L. Not a term that I'm fabricating. Ignore this. I just cut this for a pretty picture from the math resource. Sometimes you will have to solve for the slant height. It is the same process as this one, where you use Pythagorean theorem from the height and, in this case, the radius would be the perfect thing. See that square angle right there? There you go. Okay. A cone has a diameter of 10 centimeters and a slant height of 8 centimeters. Find the lateral surface area. So for the lateral surface area, we just want the second half of this equation. Pi r L. You can write L like this, or you can write L like this. I just find this to look more like a slanty L than how I would write a slanty L. So I'm going to use this. And for all problems on these focus quizzes, pi is 22/7. On some of the comps, on some of the other things, they'll say use 3.14 for pi or use the actual value for pi. Usually they won't say that because certain people don't have calculators that have that. So just use whichever the test tells you. All right, and this says diameter of 10. Now all we need to do is plug in our values for this, but it says diameter of 10, so we don't want to accidentally plug that in because we want the radius. So the pi of 22/7 is our first part, times our radius of 5, and our slant height is 8. And then we just multiply this together, and it will give us the lateral surface area. Boom. 125.71. Usually the answer choices will round to 2 decimals. If they don't, include the 4, I guess. Meters squared. That's your answer. Not too bad. I don't think these tests are too rough. They do have challenge problems, but, you know, they all do. So that's fine. Find the volume of a cone that is 1.25 meters high with a base radius of 7 centimeters. Now, I'll tell you this now because you're going to see me do it anyways. This is in meters and this is in centimeters. So you need to convert to whatever your answer choices are in. In this case, we're going to assume they are in centimeters. So I'm going to change this to 125 centimeters. If you don't know how I got that, you need to study the metric system. Centimeters, a centimeter is 100th of a meter. So multiplying this times 100 gives us this. Our volume formula is exactly the same, but instead of just big B, we are going to put our whole pi r squared times the height. So 1/3 times, and this doesn't need to be in parentheses because it's all just multiplied together. It just helps me kind of sort things out. And 7 squared here times our height of 125 centimeters. And if you forgot to change this, your answer choice would just be way too small. And it would still look like one of the answer choices. It would just, the decimal would be in the wrong place. So you wouldn't be too out of luck. But certain things do require you to convert before. Like if they gave this in feet and this in inches, you need to convert this to inches, or it will be vastly wrong. Why is it up there? It always does that. 1/3 times 22/7 times 49 is 7 squared times our height of 125 centimeters. Oh, control enter. 6416.67. Oh, I don't know why I did a 1. 6, 7. Cubic centimeters. All right. Again, not too bad. Just make sure that you're always looking out for these little things, like them giving you the diameter instead of the radius. Same sort of little trick, I guess. Just kind of you need to do one extra step. Okay, find the total surface area of a cone if the slant height is 6 meters and the radius of the base is 10 meters. So our equation for that is area of the base, which is pi r squared, right, plus pi times radius times slant height. And we have everything we need here. And we're using 22/7 times, and our radius is 10 meters, times 10, plus, 10 squared, sorry, plus 22/7 times 10 times, and it's important to note that the radius is not squared in the second part of this equation. Don't accidentally do that. Times 6. So just go plug this in. It did it again. I don't... Is it just where my mouse is when I Alt-Tab? I have no idea. Uh, 100 is 10 squared plus 22/7. And if you think I have to go back and reference too often, you're right. My brain just doesn't work correctly. Like forgetting to do the control enter every time. So our answer is 502.857. Keeping all the decimals this time because I like them. And that is meters squared. Cool. Again, not too bad. For all of these, you really just need to memorize the formulas. And there's nothing like that one polygon formula that was just utterly disgusting. I really need to make sure you need that for the comps. We'll figure that out. If you do have to memorize it. What can I say? Except, not going to make that joke. If the radius of a circular cone is 4 meters and its volume is 64 pi cubic meters, and there's a reason I kept that pi there. Normally, you would expect it in terms of this because we're using 22/7 as an approximation of pi. I think that means approximately. Anyways, we're using that as an approximation, but in this case, the pi's will cancel out. So it's easier to keep it as this, and they give you it in terms of this on the test. So I wanted you to not be startled by that. You don't need to use 22 over 7 for this case. So we know the volume. It's 64 pi. And we know the equation that should get us that volume. It's 1/3 area of the base, which is pi r squared. And we know what r is. It's 4. So we can go ahead and say 16 for 4 squared times the height, the one thing we don't know. So we just need to divide out all of these things to find the height. And the first thing I want to do is divide out pi, because that will cancel it on both sides. And all of this, since it's all multiplied together, you can do this, right? If there was an addition sign in here, you would need pi in both parts of the, whatever it's called, polynomial? I don't know. In order to do this. But we don't have to do that. So now we just have 64 equals 1/3 times 16 times height. So first we're going to multiply by 3 to get rid of this. And this will become 3 times 64. And then we're going to divide by 16 on both sides to get rid of that. And we have 3 times 64 over 16 equals our height. Did it again. I assume that's just what it's going to do from now on. 3 times 64 over 16 equals 12. So our height is 12 meters. Right? Yeah. Not that bad, right? And that is honestly, besides the challenge questions, this is about as hard as they get. There are challenge questions and they're kind of rough, but don't worry about it too much. Just try your best. A cone has volume 8852.38 cubic meters and a height of 50 meters. Find the base diameter. So using our equation, we're going to end up with the radius, and we need to multiply that by 2 in order to find the diameter, because that's what it wants. So we know our volume equation. It's just very like the last one. We have 8852.38 cubic meters equals 1/3 pi. So in this case, we do need our 22 over 7 because it's in terms of some fraction that they got using this, so we have to use it. Times r squared times the height of 50. So I am going to use nsolve for this, which normally for something this simple I dissuade from, but I find it's very easy to mess up moving multiple fractions without simplifying them first, and then it takes about as long as nsolve anyway. So you're not really saving any time here. Oh, and normally you cannot use nsolve for something with a quadratic, right? And this is squared. However, because this does simplify to just the variable squared equals some numbers, and there's no other variables attached to this, so it's not r squared plus r or anything like that, like a quadratic equation might be. There are 2 answers for this, but they are just some. So let's say we have r squared equals 25. Then we know r is going to be 5 because that is the square root of 25. But it could also be -5. But because there's only an r squared over here and nothing else, all nsolve can give you is 5 or the negative version of that same answer. So if it gave you -5, you would know, because it can simplify to this, which you can see here, there's no other r terms, you know you can safely use nsolve because it's just the negated version of that same value. Long-winded way of saying sometimes you can use nsolve for a squared value. Nsolve 8852.38 equals, and this is just normally I'd put the other part of the equation first, but you can do it either way, I think. I don't do this very often, but it doesn't matter. And this is why I think nsolve is fine here. Times x squared. You could put r, you just don't have to. Times 50? Yeah. Comma x. 13. So this could have given us -13, but we would have known that it wouldn't matter. And if you plug 13 or -13 back in, it'll come out to the same thing. Now, that's the radius. It wants the diameter. So 2 times 13, d equals 26 meters. Cool? Cool. I think so. Volume of a sphere is this. 4/3 pi r to the third. It's important to remember this third. And an easier way to remember, because these two formulas are very similar, the volume is in cubic units, right? You know, like milliliters, stuff like that. But the surface area is going to be in square meters, or whatever the unit is, square units. And this volume equation has 2 3's in it, 4/3 pi r cubed, right? And the surface area is 4, not divided by 3, pi r squared, which it's just 4 times the area of this circle that is the core, I guess, of the sphere. Ignore this bounding cylinder. They try to, like, explain kind of why these equations exist without talking about calculus, which I think is very silly. Just, these are correct. So just accept that for now. And then when you go take calculus, you can have the relative displeasure of having to integrate the volume of a sphere in multiple different ways. It's not fun. Maybe it is fun. I don't know what you like. Masochist, whatever. But, yeah, just accept that those are the correct formulas and ignore that bounding cylinder. Find the radius of a sphere with surface area that meters squared. So we just saw that our equation for the surface area is 4 pi, which we have to do 22/7 for, r squared. And we know it equals 4,538.285. And this one, I will not end solve for because it's quicker to divide this by 4 and then multiply it times 7/22. When you divide a fraction out of something, you have to flip it. So, get down there. 4,538.285, yep, over 4. And you could include the terms of the 7 and 22 in the same fraction. I won't, because I don't want to. And that will give us 361. Is that correct? Oh, yeah, sorry. That's r squared is what we just solved for. So then we need to take the square root of that. And the easiest way to pull down answers, because I have copy-paste, you can either type that again, but if it's something really long and ugly, you do control, you get your square root, and then to pull down whatever your previous answer was, you keep your cursor there and hit control the negative sign right here. And it will say ANS. You could also type that out. And it will use whatever was right there. So our answer for the radius is 19 meters. Cool. Find the volume of a sphere of radius 17 meters. So we're just plugging in our meters to the volume formula, which is 4/3 pi r cubed. Important to remember it's cubed. People very often do squared by accident, and you'll get it wrong. Sometimes the test will be nice and not put that as an answer choice, and other times it will not be nice, and you will get it wrong. So, anyways, 4/3, well, we don't even need to write this out. Let's just get right to it. 4/3 times 22/7 times r, which is 17 to the third. Got to use a little caret and hit to the third. We get that. Control Enter gives us the correct answer of 20,587.8 meters cubed. And this looks really big, right? I won't right now for the sake of time, but at some point, if any of y'all are interested, I'll kind of show you the relationship between the radius and the volume, excuse me, of a sphere or of anything, really. And I think it's kind of interesting. It kind of works the same for a cube. It's a cubic function, and it's crazy how insanely fast the volume goes up for a relatively small increase in radius. Find the surface area of a sphere with radius 5 centimeters. So we're just going to plug in 5 centimeters to our formula. 4 pi r squared. 4 times 22 over 7 times 5 squared. Oh, well, guess I'll raise it to, I misclicked. Gives you that, which is actually just 100 times 22 over 7, because 4 times 25 is 100, which I thought was a fun little accident. I thought that was so chuckle-worthy because math. 314.287. This also shows 6, rather. This also shows how accurate an approximation 22 over 7 is for pi. It's essentially just 3.14, and it's kind of close to pi on the end of this. Pi actually is 3.1415926. I don't know. This might be it, it might not. But the 1.5 is correct. I know that. So it's pretty close. Close enough for us anyways. Find the diameter of a sphere with volume that meters cubed. So again, this is looking for diameter, not radius. So we have to solve for that and then double it. Our equation is 4 thirds. Well, let's just write out the actual numbers. Y'all have seen that equation enough now. 113.143 equals 4 thirds times 22 over 7 times the radius cubed. And you can safely use nsolve for this. Maybe there are cases where you can't use nsolve for something to the third. I know you cannot use it for something to the fourth. Don't even try that. You can get one of 4 actual integer answers, which you don't want to deal with. But I will use nsolve for this so that I don't have to move around fractions, because again, I don't want to. Nobody wants to move around fractions. Nobody likes you know, I say that. I shouldn't assume y'all don't like fractions. That's just terribly rude of me. We don't shame fraction love in here. X to the third, comma, x. So 3. Our radius is 3, which means our diameter is 6 meters. Cool? All right, this is the last one. I included it. There's a problem exactly like this on the test, and it's really not that hard. I would say it's like a challenge problem, but it's not that bad once you see it. All right? So a solid pewter sphere of radius 7 centimeters is melted down and cast into many small spheres, each of diameter 1 centimeter. And this is diameter, so for our formula we got a half 1. Find the number of smaller balls obtained using this method. So maybe this looks easy to you, maybe it looks very daunting. It is pretty easy. All right? So think of this as like a dodgeball of radius 7 centimeters, a dodgeball-sized ball, and then much, much, much smaller balls with a radius of 0.5 centimeters. All right? And you are going to see exactly not how many balls could fit into here, but how many balls can be made from this, the raw volume of it, because there would be like empty space between them if you just shoved them in there, right? A little bit different. So that's a very interesting, horrifying to do problem, actually, how many spheres can fit inside of this without melting it down. But that's neither here nor there, because the melting down part is pretty simple. It's just the volume of the big sphere divided by the volume of the small spheres. Pretty simple, right? And that looks like 4 thirds times 22 over 7 times r cubed, so not r, 7 cubed, over that same thing, 4 thirds times 22 over 7 times 0.5 cubed. And because these are all singular terms, and these parts are the exact same, you can think of them as coefficients, they can cancel out, or they do cancel out. It'd be like if we had pi and pi. They cancel. Exact same deal. So we're really just doing 7 cubed over 0.5 cubed. And the answer, I think, is surprisingly big. Compared to, like, I guess if you just showed someone this and you said, guess how many little marbles you can make out of this ball of metal, you might not guess this big of a number. And it does kind of show exactly how rapidly the volume increases per radius increase. You can make 2,744 little marbles out of a big dodgeball-sized sphere. All right? Again, not too bad. don't let any of these problems scare you. If you have the equations and you have, arrested mind that can kind of logic through things, you can do most, if not all, of these problems. But that's all I got for you. Good luck on the test.